We don't know. Let's see. All right, reminder for your quiz number 1. It's going to be next Tuesday, right, upstairs. I don't think I will start just 2:30 prompt. Might be a little bit too harsh. Why don't we say 2:35 we'll start. Make sure you come in time, get seated, and then we'll distribute the paper. I'll send you guys maybe either tonight or maybe early tomorrow just about the exact coverage and also some tips for you. And by number 1, there'll be no proofs, okay, for the quiz number 1. There might be some informal justification for some property, for example. And as long as you have followed along the discussion we have had in the class, you should be okay, right? But there will be some definition questions as well. For example, what's the difference between syntactic versus lexical analysis? That could be one, right? So just review what we have covered, you will be okay. It's really one means to actually push you to study a bit, just to make sure everything is catching up, all right? All right, before that, okay, let me start with the review exercise, right? I presume some of you may have tried. Okay, why don't we talk about it? Because they might appear in your test, right? Why don't we talk about it? Okay, number 1. What is the cardinality of the English alphabet? I believe there are 27 of them, right? So if you, okay, let me just be a little bit precise over here. Give me a moment. Is it 26 or 27? 27. Thank you. I beg your pardon. Yeah, I thought it was the additional one, right? I have no idea. I will switch to iPad in just one moment. All right. Okay, over here. And this one here, what should be the answer? You don't need to give me the exact number. How do we calculate it? Yes, 26 to the power of 5, right? That's something we discussed in the class. Should be no surprise. It should be the cardinality of the alphabet, which will be 26, and then to the power of 5, which will be 26 to the power of 5, right? That one should be straightforward, all right? The next one, this one here, numerate in a systematic manner the set ABC to the power of 4. Let me write it down, and then for you to solve that, it's better to know what that really means. To the power of 4. Can somebody start with what that really means first, and then we'll start the systematic numeration. I'll show you one way to do it. You can feel free to do your own way as long as it's systematic. Anyone want to start with just telling us what that really means informally in English? Does that mean we try to concatenate the characters 4 times? And we are trying to find out all the possible ways to do concatenation. Yes?
Is it strings over the alphabet?
You tell me. Do you think that's alphabet or language?
Language, sorry.
Well, actually, I should be more clear, right? Okay, let's say this. Because potentially, if I only give you this right away, it could be language, could be alphabet. Okay, that's fair. Why don't we say this guy over here is an alphabet? Okay. Does that mean we want to figure out all the strings of length 4? Well, does that mean we want to find out all the possible concatenations to do 4 times? First or second? Yeah, all the string with length 4, yes, okay. And let's write it down first. All the string of length 4. Of course, ultimately, it's going to be a big set over here. Another thing is we need to enumerate it systematically so we can be thorough. We know what we're doing, right? What I would suggest is since we talk about the length, right? So we can start with length 0, length 1, length 2, all the way to, actually, in this case, no, because we got exactly length 4, right? I can give you another problem to work with. That might be another way. That's what I actually initially thought. Okay, it's got to be exactly length 4. So what you should do is basically, you got a string 1, 2, 3, 4, right? 4 characters there. Each one of them can be either A or B or C, right? Do you guys have any? Do you want to share your way of systematically enumerating it? I will share my way as well. Henry.
You can start with all of the first symbol.
You can start with all the first symbol, like a. Sure. Give me a moment. You mean something? Okay, I can see, kind of see what you mean. You mean like A, something like that.
No, I mean like the first string is AAA.
Okay.
Then I in a sense increment the last symbol. So I go to AAA.
Okay, I see what you mean.
Then eventually I roll over.
Yeah.
So I get AAC.
That one is good, not bad. Not bad. I would say that maybe that would be one of the ways I would do it. But when things get maybe longer, then you might able to, because you kind of say the increment concept, right? For example, if you say increment A here, that becomes B. But later on, let's say if you actually got A, B, A, where do you increment? You might kind of lose the count.
You always increment the last symbol.
Mm-hmm.
You hit C, you go back to A, then you roll over the next one.
Sure. Yeah, so there's some complicated, well, I wouldn't say complicated, there's some rule you got to follow for incrementing.
In decimal, we go 1 to 1 to
Yeah,
9.
sure.
Then after 9, go back to 0, go to 1.
Yeah, so in this case, it will be a number system that's base 3 that you have to know how to increment. Sure. Okay, that's one way to go. I wouldn't mind. Another way I can show you guys to do is by drawing a tree. Not too sure if you guys tried it before. Okay. Starting point. Branch out like a B tree. Either we can go for A or B or C. That's for the first character, and second one, and third one. A, B, C, A, B. I'll just do length 3, so you get an idea for length 4. A, and then B, and then C, right? And of course, you can go on. This will be ABC, ABC, ABC. How do you enumerate all the strings? Basically, the first one will be A followed by A followed by A. And then the second one, A followed by B followed by A, and etc. That's another way to do it. That way there, you don't necessarily have to increment. Of course, you don't have to be subject to that rule, but you just enumerate A, B, C. The disadvantage of that is the tree gets big at the bottom. I agree. So whichever way you like, it's up to you. Either go for Henry's way, like a number system for increment, or go my way of B tree, either way. Unless you got a third way to do it. You want to share. Okay, guys? All right. Everybody kind of follow what's going on here? All right. You can go either way or your own way to systematically enumerating all the strings. All right, and we also got 3 and also 4. We discussed 3 already, I think. Robbie, yes.
How one does this to listen everyone out?
Do I have?
You want us to list them all out?
Well, of course, according to this question over here, yes. But of course, in the actual quiz, I'll make sure I'm reasonable, right? Maybe I'll only want you to list maybe certain things, but it'll be clear. I'm just saying for this particular practice here, yes, you want to list them all. Yeah. I know. For this one here, yes, it's like a 3 to the power 4. It's a lot. Yes. But in the quiz, I'll be reasonable. Good. We got number 3 here, which we discussed, and we got number 4, number 4 over here. First of all, is this true? Number 4. Is it true or is false? We're basically talking about 2 alphabets over here, right? We've got 2 alphabets, alphabet number 1, alphabet number 2. And then we're saying that if it happens that the first alphabet has no more element than alphabet number 2, then the language from there is going to satisfy this relation. That's what we're saying, right? Before I sketch the solution a little bit for you guys, which is quite straightforward according to definition, do you guys have any thoughts to share to solve this one here? Anyone? Or it's too complicated? It's not, right? I hope. Go ahead. Yeah, sure. The implication here, well, you think about what sigma 1 star really mean, right? Sigma 1 star means all the strings you can derive from sigma. All the length 0, length 1, length 2, and etc. And sigma 2 star, basically all the strings of any length you can derive from alphabet number 2. And we are saying that this set over here is a subset of that, which means it contains no more than the elements here, informally speaking. But you know what subset really means, right? Anybody other than Henry would like to share? Huh? It's true, I agree. And that's a very good first step. How about second step? How would you informally justify? That'll be okay. You're getting somewhere. I can see you're trying to make some example in your mind and trying to see, but it's not exactly clear how the subset can be satisfied. Still not very clear. Okay, Henry.
Okay, I don't want to make this completely formal.
That's okay.
But my idea is consider not a sigma 1 star, but consider sigma 1 to the power n.
Okay.
And sigma 2 to the power n. If sigma 1 to the power n is a subset of sigma 2 to the power n, then let's suppose we append a symbol from sigma 1. So now we have a string. Let's append a symbol.
I see what you mean.
1 to the n from sigma 1. So now we get a new string in sigma 1 to the n plus 1 because we appended a valid symbol.
I see what you mean.
And we do the same thing in
Yeah.
sigma 2. Sigma 2 to the n append a symbol from sigma 2.
Yeah.
A string in sigma 2 to the n plus 1
Yeah.
is also valid. And since the symbol we appended is the same symbol, right? And since we know that the one opposite subset of the other, we know the symbol exists in both languages.
If I understood correctly, you're basically doing like a mathematical induction.
Yes.
Okay, very good. So guys, I will highlight a bit what Henry just said, which is brilliant, about how you can prove by mathematical induction if you want to go formal. I will sketch that very briefly, and then I'll go another way, which you can also use to justify. Okay, two ways. Okay, so I think in order for you to prove approach number one, right? You basically want to say sigma 1 and then sigma 2 implies sigma 1 star subset of sigma 2 star, right? Over here. And you basically prove by mathematical induction. And I presume you got to do some base cases first, right? You can just do maybe sigma 0. That could be a good base case.
I didn't know how to do the base case. That's why I said it wasn't.
Yeah, you know what? Base case is incredibly straightforward. What's sigma 0?
No, I wasn't sure how to notate it properly.
That's okay. Since I said there should be no proofs for Tuesday, so you guys don't. Well, I think for number one, for your knowledge, it might be useful for later. But I'll just cover that quickly. So for base case, it's going to be, for example, you can say sigma 1, 0, a subset of sigma 2, 0, right? Basically, we are talking about the n over here starting from 0 and all the way onwards. And is this satisfied trivially? William, good. Because, let me explain. I'm pretty sure that's what William's thinking. It is this. And this one here is this. I'm pretty sure that's what you're thinking, right? Good. True. Satisfying. That's base case. All right? And actually, this is very trivial because for any given alphabet, that will be the case. All right? And then I'm going to go more about what Henry just said. You have to assume some inductive hypothesis. Inductive hypothesis, right? Hopefully these terms are not really strange to you. That's something you may have seen already in, I'm not sure, maybe a 1019 or some earlier math course, right? Let me do it quickly. I wouldn't do the whole proof. So you can assume. Assume this is the case where n, let's say, is larger than maybe 0. All right? That's the inductive hypothesis. And then you want to prove the following. You want to prove that sigma 1, n plus 1, sigma 2, n plus 1. What you have to somehow justify for this proof case is to say If you compare this versus this, what's the difference? The length of the string. One is about n plus 1, the other one's n. So like what Henry said, you're basically trying to concatenate some character chosen from 1 into this. You're choosing another character from here and concatenate to here. Right? Append. That's a more precise way to say that. However, since we know this is the case, any character you choose from here for appending into here must be a member of this. That's a subset relationship. That's kind of insight you have to justify, right? Let me write it down. You guys can think about it. Okay, so to append to sigma 1n is guaranteed. To append, let's say some character C, which is in sigma 1, that C also belongs to sigma 2, right? Because of this. And you can actually complete the rest. That's kind of a sketch if you want to do it formally. Mathematical induction, which is awesome, which I like. Another way to do it, slightly informal. Approach number 2, right? Let me put it down here. Sigma 1 subset of sigma 2 implies sigma 1 star subset of sigma 2 star. What I would suggest is like this. Let's start with this. Sigma 1 star. By definition, what is that? What's the definition that we talked about in the very beginning when we say sigma star? William. Yeah, I agree. So how should I write it? How about help you out? What about all the strings chosen from sigma 1 that's of length 0? How would you write it?
I guess the set of W.
Yes, you're basically talking about what sigma 0. Yeah, that's okay. All right. And that'll be sigma 0 union with sigma 1, 0, sigma 1, 1, union sigma 1, 2, union, etc. Agree? Okay. You can easily justify that this guy over here, for example, is a subset of sigma 2, 0. This one is obvious because just epsilon. That one is obvious, trivial. Union with sigma 2 and then 1. How would you justify this, for example, this one here? This one should be quite obvious too, right? This one here is about choosing any character from here. This one here is about choosing any character from here. But given that it's a subset of that, so this must be a subset of that. Do you guys agree? Okay. You do a similar argument for length 2 as well. Similar. All right? You can see it's totally different two approaches, but hopefully they will meet the same goal. And then you'll do that. And guys, by the way, why would this be useful? I said this one here is a subset of this. Why is this useful? Why would I need that? It's because this guy over here is the very definition of this guy here. Right? That's how you can justify it also. I wouldn't say this is completely informal, but if you don't feel comfortable about mathematical induction, you can also go for definition. That's fine too. Are we okay with this? Any clarification do you need? I think a mathematical induction is awesome. I think we definitely will need it at some point, hopefully today, when we define the transitional behavior for DFA. Right? But this one is good too. You can just apply the definition. All right? All right, final call if you guys got any questions. Okay. Can I take silence? Is no questions? Thank you. Hopefully it's not like I don't care, right? Okay, hopefully not. All right, guys, very good. Awesome. Okay, let me see languages, and then why don't we do just a few? I think for others, you can also try and then come back to me if you really want to check your answer. Why don't we try this one here? Okay, I'll talk about languages. Okay, for this one here, how do we use the, let's say we use the set comprehension. When I say as formal as possible, most likely I really meant set comprehension. How about this one here? It's a warm-up. Read it together. It's going to be a language over the alphabet 0 and 1. All the strings beginning with some zeros, or maybe no zeros, followed by at least as many ones. For example, if you got 2 zeros to begin with, you must get at least 2 ones, or 3 ones, or 4 ones, or 5 ones, and etc. That's kind of the pattern. Okay? Set comprehension. If anybody would like to try, I'll be more than happy to write your answer here, and we can give you feedback before I call Henry. Henry is always saving us, but before that, can anybody save themselves quickly? Don't be shy, please. I'll give you guys 1 minute to think about it. For the second one, I can go a little bit quicker, but just for the first one. You'd rather think about it hard now than on Tuesday, right? Anything's okay if you want to mention that. Anything's okay if you want to. William, or you might, okay, how about call him first? Okay. Your name? Pasha? Okay, Pasha, go ahead, please. Let me switch to iPad. Oh, everybody know what the problem is, right? Good. Go ahead, please. I agree. Sorry. Go ahead, sorry. XY? Okay, sure. Vertical bar? X belongs to? Okay. 0, 1? Just 0. Just star. Okay, sure. Y belongs to? 1. Plus. Okay, sure, no problem. I'll keep that. And that's it? Okay, very good. I like the answer. I wouldn't say that's right or wrong yet. So guys, here's another kind of question I can give to you. I might say, does the following set comprehension correspond to the language of this one here? That could be a question. If you believe it's the case, just say yes. If you don't believe that's the case, say no and give me one counter example. In the sense that that example there should belong to one language but not the other. So they're not equivalent. You see what I mean? Okay. Can I stare at that for just 1 moment. Not 1 minute might be too long. Okay, stare at that. Do you guys think this set comprehension here correspond to this one here? Who would say yes? Oh, sure. Okay, sorry, you're the only one. But it could be right, you know. There's no democracy here when we talk about science, right? You could be right. Everybody else could be wrong. Okay? For those of you who thought that's wrong, can you give me one counter example? How about I go with you first? Okay, go ahead. 0, 1, 0. Okay. But 0, 1, 0 seems to not belong to any language, right? Do you agree? Oh. Yeah, Matthew said you're wrong, actually. I think that's a nice ring. Yeah. Okay. Actually, guys, this is not right. Okay, I tell you why. You want to choose a string that belongs to one language but not the other. But if you choose one that does not belong to any, you're not helping. You see what I mean? Okay. So I'm afraid, sorry, this one may not be good. And let me be a little bit more precise, and then I'll point to you guys. You know, I think it's really good for you guys to practice. Let's say this is called L2. And for the L1, it's actually the original explanation. It's about as many ones as zeros. Right? Actually, start with 0. Okay, L1 is what you saw on the slides, and L2 is what Parsha actually suggested, right? Okay, this is another thing. Anybody else want to give a counterexample? William, go ahead.
0, 0, 1.
If you got 0, 0, 1, sure, okay.
So it's in L2 because it's got some zeros and it's got some ones, but it's not in L1 because it has 4 zeros.
That's brilliant. Okay, Parsha, for example, that's one way to see. Even for yourself, you come up with the first version like what you have over there. Be critical to yourself to see whether you can find a counterexample like this way. Okay? On the other hand, that's good. Another question for you guys. Apparently, William helped. Oh, sorry, I'm going to make this. Okay, does not build on L1. Very good. Is it possible to find a string that belongs to L1, but it does not belong to L2? Is it possible? It doesn't seem to me it's possible, right? Because L2 is a strictly larger language. So it turns out L1 is a proper subset of L2. Okay? And this one here is, yep, that's something you want to, so that means there is not a string S such that S is actually in L1, but S is not in L2. It's simply not, right? Yeah, think about this little example here, right? That's how we criticize about the example. Hopefully, Parsha wouldn't mind, right? Just to learn together. How do we improve it? Robbie, you want to try? Yeah.
Can you get the cardinality part?
You know what? I wouldn't go for the cardinality. Yeah, I wouldn't go for the cardinality actually because we talk about the pattern of the string. So I think normally you wouldn't. In this case, you wouldn't go for the cardinality of the string. That's okay. Yes, please go ahead.
Something like 0 to the power n.
Let me write it down if you don't mind. Let me write down exactly what you say. L3 would be. Yeah, go ahead.
0 to the power n, 1 to the power n, such.
Also n.
N.
Okay.
Such that
Mhm.
is greater than or equal to.
Are you sure?
N is greater than.
Thank you. Maybe I heard you wrong. Yeah. Yeah. Of course, you may, well, to be picky, you may want to say both of them are actually natural number. You may want to say n larger than or equal to 0 and also n larger than or equal to 0. You want to say that. But of course, we didn't define what it really means when we got negative. So I wouldn't be so picky for the written test one. But. So guys, I think this would be a reasonable answer. That's correct. Okay, pretty straightforward, but I think it's a very valuable lesson for us to know why this one wouldn't be so ideal, right? Both you should know, all right? And why don't we look at the second one as well? But the second one looks more complicated, but similar idea. Now the alphabet is actually ABC. Begin with some A, possibly none, followed by some B's and some C's, such that the number of A's is at least as many as the sum of the numbers of B and C's. Well, it's even hard to read, right? But I see the idea.
Just for the last example there, like the one you just drew, could you put absolute value instead of putting whether it's greater than or equal to?
Where?
The absolute value of m and n instead of putting.
Not really, because if you put absolute value, right, you're kind of suggesting that m and n might be negative, right? So you want to say they're both non-negative. Yeah. Mm-hmm. Okay, sorry. Back to here. Parsha, do you think you may have some inspiration for this? You want to try? Give me a moment. Yeah, let me talk about it. Yeah. All right, guys, you pretty much know what it is about, right? Let's write it down. L. Huh? Oh, you're still reading it? Okay, that's okay. Let me find somebody else. Anybody want to contribute? Henry. Oh, let me switch to the iPad first. Yes.
X to the n, y to the n, z.
ABC you meant, not X, Y, Z. The alphabet is ABC.
Oh, yeah, yeah, yeah.
A to the power of
N,
M or N.
n.
Okay.
Then b to the n, then c to the o.
How about we do X, Y, Z if you don't mind? Thank you. Just easier for me to hear, right? Okay, C to the power Z. Okay, awesome. And then,
Y is greater than, okay, so x, y, z are all natural, then
yeah, I agree. Okay, let's say X larger than or equal to 0, Y larger than or equal to 0, Z larger than or equal to 0. Or you can say alternatively, X is a member of natural number. Either way. Good. And then,
y is, actually, can you say y is equal to 1, z greater than 1?
say it again.
Can you say y is greater than or equal to 1?
Yes, you can say that if you want to. Well, they are natural numbers, so you can do any natural number operation.
Where specifically?
You mean where?
Like where you say y greater than or equal to 0,
Mm-hmm.
is y greater than or equal to 1?
If you want to, I can do it.
Yes, I want to.
You want to?
And same for z. Then finally, x is, wait, can we take it again? I forgot what it is.
For sure. Yeah, I mean, you want to look at this part here.
Okay, and then
Yeah.
a is greater than b plus c.
Why would you need to put these two over here?
This is some means, which implies more than one, more than like at least one.
Let me ask you, okay, that's another good question here. That's another good thing. Okay, let's say this, right? This is L2. L1. All right, let's do it again, the exercise. Let's say L1 is what we have in the slides over here, right? Let me try. This might work this time on my computer. Let me give it a try. If it doesn't work, I will just take it for granted. Sometimes it works. There we go. Please paste. Also depends on the speed of the Wi-Fi. Apparently it's very slow. I'll bear with that for 10 more seconds, otherwise I'm going to cancel. And sorry for the poor show. Usually for the very first one, it's so slow. So slow. Come on. It's something called universal clipboard, for those of you who might be a fan of Apple, right? I'm not sure if you ever use it. Okay, never mind. Okay, it might come out at some point. Let's say this one here, I'm get rid of it, and then I want to just get another one here. Sorry about that interaction. I'll try not to do it again. Okay, good. So this part over here is just whatever you got in the slides, all right? Are they the same language? Are they the same? That's a question, right? If they are, you can say they are. If they are not, I'll let you pick one more time. I think the highlights for Henry's solution is about y larger than or equal to 1 and z larger than or equal to 1. That's very important to note. Would that be the same as saying the number of a's at least as many as the sum of b and c? That's a question. Are they the same languages or they are not? I see that you said they are not. What? Give me counterexample.
Since we're saying B and C are at least 1, we need A to be at least 2.
I agree. So can you give me one counterexample? That counterexample, again, should be in one language, but not in the other. Henry, you kind of see what the issue might be?
So, like, the definition does say that A has to be, like, the number of A's has to be more than or equal to B plus C.
At least as many.
Yeah.
It could be the same.
Right. But, like,
A could be like a none. Could be no A.
right. But what we had in L2 was since we're specifying that B and C are at least 1, then, like, do we need to say that A should be at least 1 plus 1?
That might be also too restrictive because here we say A can be no A's, right? So you can definitely you're definitely on the right direction, Matthew.
Well, if you can have no A's, and A has to be at least as many as the sum of B's and C's. If there's no A's, that means there's no B's and no C's.
I agree. So, can you? Okay. Now can you give me one counterexample string which exists in one language but not the other? I agree with your explanation. It's absolutely spot on. But I just need that string.
0, 0, A, B, C. No.
Actually, ABC will satisfy this, will also satisfy Henry's language specification. Let me just put it out. Guys, I think this is really important, right? Don't think this is wasting your time. It's actually absolutely important. For example, ABC is one example string that's in L1 and also in L2.
Exactly. ABC satisfies neither because there's less A's than B plus C.
Larger than or equal to. Oh, guys, am I confusing you guys? I thought the other way. I'm also just confusing you guys. I admit, I thought it was B plus C larger than or equal to A. Okay, that's what I thought. Sorry. But, I'm not taking the written test, so that's okay. Yeah, that's okay. Okay, we'll see how it goes. Okay, let me take back. So when you watch the recording, forget about what I said in the last 5 minutes. Okay? Okay, very good. Okay. So in this case, I think this might just be fine. However, I would suggest try another one. Yeah, I think for next year, I'll change the specification a little bit so that it actually wouldn't get me confused. All right? So guys, I think this one is actually fine. Okay? It's actually okay. All right? However, I do encourage you to try what I was confused about. Try another one. The number of B and C's at least as many. At least as many as the number of A's. That's what I originally thought. All right, try that exercise. Question? AB? You mean which language? You mean this one here? AB over here, let me see. Actually, that might be good. AB over here, that means AB, A1, B1, and then C0 over here, right? In this case, yeah, actually you're right. That's one language that's actually in L1, but not in L2. Yeah, sure. No?
My notation is correct. It should say x is greater than equal to y plus b. In the second operation.
Oh yeah, of course. Yeah, that should be here, right?
Yeah.
But you can see here, this string over here, that one there actually was definitely be in L1.
It says we have some C's.
Did I say that?
Some C's.
Yeah.
Okay.
Some C's.
Yeah.
Some C's.
Yeah, could be. Yeah.
The English is ambiguous.
I know. It's inherent the case. Okay. Yeah. Okay. I would say for this one here, okay, that's a good sign. I think in the quiz I'll try to be as precise as possible. I think. Okay. Yeah. Matthew, go ahead.
I think the problem is it causes a logical contradiction if
Mhm.
if you can have no A's, but you have to have some B's and some C's.
Yeah, I agree. So that's why this English part, I agree, itself is not exactly, precise. Mm-hmm.
I just think
Mhm.
it's implied
Mhm. Yeah.
possibly no A's. It doesn't say you have to have a P square.
Well,
So the English implies like something weird.
so let's not worry too much. I think in the test, I'll give you something hopefully straightforward to think about right away. Okay, but I think the derivation process we are trying, I think is still worth your attention. All right, good. Thank you guys. I think you guys really pay attention, which is good. How about this one, number 3, and then we should really move on. How about number 3? How do you justify that? What do you have to do to justify? This one just by definition. How about the first one? Actually, the first one, it's almost like just by definition. Let me put it here. We're going to say sigma star is a language over sigma. Okay? How do you justify that? What you need to apply the definition to is, how do you define a language over sigma? That means the set of all strings of all the possible length, which would be sigma star. Agree? And is sigma star a subset of sigma star? It is. Yeah, that's how you justify it, just by definition. So this is not a hard question here, but that one just tests you whether you know what definition to apply. All right? Similarly, if you want to ask whether the empty set is also a language over sigma, you want to ask yourself, is empty set a subset of sigma star? Indeed, because empty set is a subset of any set, right? And similarly for this one. Okay? All right, you can think about 4 and 5, right? Think about it. If you bother to check your answer, come to me. Otherwise, I can check your answer in the written test. Either way, okay? But just do it. I think it'll be worth your time. All right? All right, any questions so far? Just thought I would just go over some solution with you. I think we can do that for other lectures as well, right? Just get you more prepared for the written test. I mean the quiz. All right? Let's move on. And I think we were, let's see. I think we finished that already. And also we finished the basic and recursive, the base case and recursive case for the regular expression construction. I want to do one more exercise for you, one slice, right? If you already got a slide, I would suggest not to peek just yet, right? I think this will be also important to know how to apply, right? What would this be? First of all, you want to understand what that really is trying to say. This is a regular expression, first of all. This is a regular expression. And of course, thanks to Henry, we know that it's this in Perl or JavaScript, right? But let's not worry about the syntax. That's a plus operator in the regular expression. And we want to ask, if you write this and use a regular expression, what should be the corresponding language, or like a set of string? What should that be? I'll give you a little hints. We talk about how you can define the regular expression operator using the language operator. If I just show you very quickly, well, that's exactly the slide we just talked about over here, right? That's the 2 slides you want to look at. And what about plus? What will be the plus about? Plus should really correspond to which language operation? Union? Agree? Not concatenation, right? Union. So that should be, by definition, empty set, just empty language. Union with the language of L, right? That one there should just be L. Okay, that was easy. But the second one here, and you should know that it doesn't matter if you put the empty set either in the left or the right. Doesn't matter. How about this one here? This one is more challenging, which I want to talk about. This is a regular expression. Empty set, followed by L. So we're talking about concatenation, so that you know, right? This is very different from this. One is about plus, the other one is about concatenation. What would that be? What would be the corresponding language? Not really intersection. Not really. But we already said it's concatenation, so it's not really intersection. If you go back to the language operation there, there's no intersection there, I don't think. Concatenation. Not the final answer. Not really. Brilliant.
The final answer would just be L.
No. It's a very, I know, it's a very logical guess, either empty set or L, right? Not really somewhere in between. I can tell you that another good guess would be just epsilon. Another good guess, which turns out to be the answer for this one. However, that's not enough. We need to justify that. It turns out the answer to this is just a set with a single member, epsilon. But why? Weird, right? Help you guys a little bit. Do you agree? This one is going to be concatenation, right? Okay. First, okay. Oh, actually, that's the next one. I'm again confusing yourself, confusing you guys. For this one here, but why is that empty set? Brilliant.
I still don't think it's the empty set.
You still don't think? Did you say L? You said L before, right? Okay. But why is that empty set? Can you tell me the definition for language concatenation?
I guess just something from the first set.
I agree. Yeah. So for example, X, Y over here, such that. So concatenate X and Y. X should be chosen from empty set. Y should be chosen from L. And do you guys see why this guy here will be empty set? Right? Because there's no such X. So there's no way you can come up with any member for this set. So that will be empty. Okay? Really, you were right, but just the justification part. All right? And the next one, the trickiest one. Empty language, or like empty set, cleaning star. What would that be? Well, again, like what I said, you can, if you really want to take a guess, it can be, well, there's no L here, so I don't think L is a good guess. Could be empty set, could be epsilon. Let's do this one here. Every time if you actually encounter something you're not too sure, see if there's any basic definition you can apply. What does it really mean? Let's not worry about the empty set here just yet. What if I say L star? By definition, what's really L star? Which we just did, right? You want to tell us, if you remember? Thank you. Absolutely. So now we just replace L by empty set. Okay? Thank you. That's a very good first step in case you get stuck. This one to the power of 0, union to the power of 1, 2, etc. All right? By definition. Let's figure them out individually. What is this? I give you guys a choice. Is this epsilon or empty set? In order to determine your answer, you want to understand what empty set to the power of 0 really means. Empty set is a language, it's empty, right? When you say a language to the power of 0, does that mean all the strings of length 0 or 0 concatenation of anything chosen from the language? The former or the latter? Should be the latter, right? Yeah, you guys really want to make sure when we say, again, I'm pretty sure this will appear in some form in your test. When I say an alphabet to the power of something versus a language to the power of something, you want to be very sure what the distinction is, which we did last time. Right? Just make sure you actually clarify on that. For this one here, we are saying the language to the power of 0. That means we want to do 0 concatenation. You think about 0 concatenation, that means nothing to be concatenated with, just epsilon, empty string. Okay? That's how you justify just for this one here. Union with. What about empty set to the power of 1? Should that be epsilon or something else? That one will be, actually, William, let me ask you. This one will be actually somehow related to your answer. How do you think what empty set to the power of 1 is? Should it be epsilon or empty set? Why? Yep. Thank you so much. That's exactly right. All the x, right? Just one concatenation, right? And then x is in the empty set. But nothing is in the empty set. So this part over here would just be empty set. And you follow the same logic for all the other exponent. Ultimately, you only get this back. So this would be the answer. All right? Guys, I would say this one is tricky. But I think the main thing to pick up from this example here is you want to know why empty language to the power of 0 is just a singleton set versus others you just get empty set, right? I think that's also gives you some insight about concatenation, how we do things, all right? And the final one, I'm not going to trouble you, right? That's exactly what you'll see on the slide, but we should really derive them together. This one here, right? You guys will figure out why it should just be L. Because, well, very quickly, this empty set star, we know already it's just epsilon. Only one thing to choose from, which is empty string. Prepending empty string to anything is going to be that original thing. No effect. So that's why it's going to be just L. All right, think about these exercises. I'm pretty sure they will help on Tuesday's test. Okay, so I think let's do some quick exercise over here. This could be something you will be expected to write on Tuesday. We can discuss my answer here, but I want to see if you guys got any quick answer for this. Let's say we want to come up with a regular expression for, let's say, order strings which got alternating zeros and ones. For example, 0, 1. Actually, 0 wouldn't be considered as alternating. 0, 1 or 0, 1, 0 or 1, 0, 1, and etc. Alternating, right? Should I give you guys some time to draw down some answer, and then I will just maybe find one answer from the audience? Should I just randomly pick one this time? Okay, take 1 minute or two, and then we'll talk about it. I don't feel bad if I pick you up, but you don't really have an answer. That's fine. Give it a try. Alternating zeros and ones. Just for your guys' information, you want to make sure, for example, 0 or 1, they are considered as not legal, right? They are not good, right? They are not alternating. On the other hand, if you got 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, and etc., they are okay. Okay. I do have one textbook solution on the slides, which I can definitely go over with you, but you can just try, right? Basically, whatever regular expression you might give to me, I'll look at them and try to see if there's any string that's covered by the regular expression but not covered by this, or vice versa. I'll try to disprove, basically. If I cannot really find it, then you might be right. I'll be thinking on the fly, of course. If I can also give you feedback later. We'll try. We'll do that quickly. Done. Why don't we try with you? What's your name again? Oh, Matthew as well. Okay, 2 Matthews, which is awesome. Okay, Matthew, go ahead.
Okay, so
Yep, go ahead.
should I just come up and show you what I have?
Why don't you be my guest? Use my pencil if you don't mind. Just write it here. There we go.
So,
You can just write. That's okay. Just write.
okay, so the reasoning that I have is that we want a sequence that is at least 1 or more characters, or
Mhm.
at least 3 characters, I guess, because we want. Does 0, 1?
0, 1 is okay.
0,
It's,
1,
it's
okay, so
alternating.
Yeah, okay.
Mhm.
So
At least 2.
2 or more characters.
Mhm.
Actually, hold that thought. Okay.
If you want to think more, that's okay.
That
So
counts as alternation. I mean, I guess, so what I was going for here was.
why don't you put down whatever you got, and then we can discuss it. How about that?
Okay, sure.
Okay. It could be, one
So this
possible
isn't quite
answer.
the solution then, but what I was going for initially was essentially we have 2 cases. We have something that starts with a 0, or we have a case that starts with a 1. And we have alternating 1, 0, 1, 0.
Just go ahead. Just put it down, please. Yeah.
Sure. So here we would have, 1, 0, however many times.
However-
It designate 1 plus.
If you say at least 1 time, that'll be plus. If you say just
Okay.
0 more times,
Sure,
yeah.
let's go with that. So we either have a group that looks like this, or we would have the other one that starts with 1 and then.
You meant plus, not vertical bar, maybe.
This one?
Yes.
No, I meant, is that?
Yeah, it should be plus for the regular expression operator.
That's an or?
Yeah, that's an or. Yeah, just remember, that's a syntax. Yeah. Thank you.
All right, cool. So this or we're dealing with a similar thing here where we have 1, 0 plus. But
Okay.
of course, these cases don't work then.
Yes, yes. Yeah, thank you, Matthew. That's awesome. I think I get very close. Thank you so much. Awesome. Thank you, Matthew. All right, guys. Let's say if this is one answer, I can also give to you and ask you whether this regular expression will accept exactly the same language as what I described in the problem, right? Of course, you guys' job will be to find some counterexample. As Matthew correctly pointed out, this one over here, for example, let's call this, let's say this is L1, right? This is L2. And we know that 0, 1 is a member of L1. But 0, 1 is not a member of L2, right? Because what if you got some length that's more than, well, it's always got more than 0. 0 and then 1, 0. That's the shortest one you can get, 0, 1, 0, which is not really covered, right? So that's not in there. But Matthew, that's pretty close, which is good. All right. Why don't we take a quick look of the textbook solution? Okay. That one there actually start with something kind of big, but you can try to simplify that along the way. Well, let's take a look. Let me now go back here. Okay, and then, okay. This one, 0, 1 star, is alternating. Would it work? Work for some. But what about 1, 0, 1, 0, 1, 0, right? That one is not really covered, right? So this one is not complete. Similarly, how about this one here? Do you think this will work? Absolutely, exactly. Maybe you want to end the alternating sequence with 0 or 1. It's not covered exactly. Very good. All right, and this one could be a solution, right? This one, I'll go over with you quickly. You can think a little bit further after class. We got alternating 1, 0, 1, 0. Either you start with a 0 or not. Also, you got alternating 0, 1, 0, 1. You can start with a 1 or not. Okay? And this will be good enough answer. You get 4 marks if you got this one. However, if you want to go a little bit more simplification, you can do so. Brilliant.
This one accepts just 0.
This one over here.
Because it could be, like, if you just take the first one 0 and then the cleaning start thing. If the cleaning start thing is nothing, you just put 0.
Maybe we can just pretend like that story.
Yeah, I agree with you what you mean. Somehow I got some inconsistency over here. I agree. Okay, like what Matthew said, can we just say temporarily, let's say 0 is actually allowed, just for now. Yeah, definitely my slides are not perfect. I definitely should improve over time, for sure.
On the quiz, can you provide examples of strings that are accepted and not?
Yes, yeah, that's fair, yes. Yeah, Henry's request was whether or not I can provide like a string for, let's say if I give you some English description, can I give you? Yes, I can. Yes. I'll try to be nice to you guys. I'll give you some boundary cases as well, not just a general case. That's not a problem. Yes. All right. Right, let's say this is the one. How can we simplify that? Well, pretty much like programming in Java. If you see some repetition, for example, 1 0 star, 1 0 star, you can factor that out into some helper method, right? Well, basically like an algebraic expression, right? That's what you will get. You basically factor out 1 0 star and put it here, and then it can either be 0 or nothing, epsilon, right? Or you can go for 0 1 star here, and then you can start with 1, or you can start with nothing over here. You don't necessarily have to get to the ultimate solution over there, but that's just a shorter. Okay? All right, so that's about some exercise to go over. And that will be some review exercises again for you guys. Of course, at this point, I don't really have any, but hopefully the English description could be ambiguous. You can give it a try. If you want to check answer, you can let me know. We should have hopefully about 15 minutes or so, right? Okay, good. Why don't we take a 2 minutes break? You guys might be a little bit tired. 2 minutes break.
Confused for the already one. But you can also start with one, right? Why we?
Which one? Oh, you mean that example there? Yeah. Which one? Sorry. This,
Yeah.
Oh, you mean here?
Yeah. Yeah. This one.
This one, yeah, it may. Yes, it may start with 1. So you can see here, it's like a 1 0 repeating, and then before that, before 1 0, you can either have 0 to begin with, or you have nothing to begin with. Right?
Oh yeah.
Is that what you're asking?
Yeah.
Okay.
Okay. Sorry. I got it now.
No worries. No worries. All right, guys, 1 minute, and then we should get started. You okay? Today? No. I think we got good number today, so that's fine. All right, let's resume. Okay. I believe that's the maybe last topic about regular expression. Yes, I believe that's the last one. Okay, let's see. Last one, pretty easy. Just about operator precedence to see if you don't have any parentheses in your regular expression, how are you supposed to handle the effects of the specification? Let's take a look. I'll give you some example. So that's something you will have to know, right? So think about this. In decreasing precedence, meaning that this will be the cleaning star, and then concatenation, and then union, right? So that's the principle, all right? And we'll do example, don't worry, okay? Having this in mind, what I will do is, let's do some example here. Okay, I think you're pretty familiar with this pattern already, right? If I give you, let's say, 2 regular expression, the question could be, are the 2 regular expressions equivalent, meaning that they denote the same language, exactly the same? If you don't think that's equivalent, is there a string in one language but not the other, or vice versa? Right? That's kind of the pattern. So I wrote it down there, so you want to make sure you understand the pattern of reasoning. Are these 2 regular expressions denoting the same language? I heard no, that's good, but just don't forget, the reason we're doing this is because when you don't have any parentheses, you have to know how to parse it, how to treat it, right? The order of evaluation in some way. Apparently, for this one here, we got concatenation, we got cleaning star. Which one should go first? According to our precedence rule, I will let you cheat. Cleaning star should go first, right? That means this one here would be as if we wrote 1 and then 0 star. As if they are equivalent, right? That's the point, all right? Of course, if I give you longer regular expression without any parentheses, you should know what they really represent. I'll give you some simple ones in the class, okay? And why don't we leave these two as exercises for you, but let's do this one only, okay? Are these two languages the same? If you don't think they're the same, can you give me one string that's in one but not the other? And before that, let me just say this is L1. Let's say this one denotes L1. And this one here denotes L2. Matthew, go ahead.
So if they're not the same, in the first language, we have the string existing as 1.
Just one? Okay, 1 belongs to L1.
And we will not see
Yep,
that in the second one.
I agree. I agree, thank you. That's definitely enough to prove that these two languages are not equivalent. But just for completeness, can we find another string that's actually in L2 but not in L1? Is it possible? Let's give it a try. So let's say 1, 0, 0. Apparently, well, 1, 0, 0 is in L1, right? Yeah, I know. I want to find the opposite. I want to find a string. I just give me another example. So I want something that's not in L1 but is in L2. 1, 0, 1, 0. Apparently, it's not in L1 because you can see it's 1 followed by as many 0 as you like. And then 1, 0, 1, 0. Yep, it's basically alternating 1, 0 for as many times as you like, including 0 time. Yep, exactly. So hopefully you guys got the idea. Right? Of course, if one language, for example, hypothetically, if L1 is just a subset of L2. In that case, never mind. I don't want to get too complicated. That's okay. All right, so when you're given two regular expressions, just remember these are the three things you want to be able to reason about. All right, good. And for the other two, you can try the exercise yourself. All right, and that's about it for regular expression, right? We only got about 10 minutes, so I was thinking about I should really cover the formulation for DFA. I don't think we can really get there. Let's get as many informal stuff about DFA as possible, and that's it, all right? Let's see how much time it will take. Okay, DFA, it's a finite state machine which accepts or recognizes a pattern of behavior similar to regular expression. You can think about the only difference is one is textual, the other one is diagrammatic, okay? For lexical analysis, that's what just need to know the definition of lexical analysis, just a pattern of the alphabets. Okay, and then let me see, set comprehension. Okay, so now basically when you are given language like this, you want to think about whether or not you can draw DFA for that. Do you guys feel more comfortable for drawing DFA or writing regular expression? Which one do you feel more comfortable? Or both? Maybe both, right? Hopefully. We'll see. Good. Anyway, so I think these are the very typical ones you actually learn, maybe from 2001. So I'll let you guys try on these. They are very straightforward. If any one of them you are not too sure, come to me, and then we can work on that, right? So we don't have to spend the time in the class, right? Actually, for one of them, we're going to see some DFA example, like alternating. We'll see. Okay, and then this one pretty straightforward, right? I don't need to even need to explain. Just to remind you, we got things called starting states, incoming, outgoing edges, and also we may get more than one final states, right? Just remember terminology. And when we come back on Tuesday, we're going to formulate the DFA, especially for the transition function. We will get something that Henry likes the most, recursive definition, which is fun. We're going to do that on Tuesday, okay? Not today. Okay, for this one here, you guys can try, but I think this one here, I'll just show you the DFA over here, okay? So what you can do is when you go back, try to see if you can convince yourself that this indeed is the DFA that is actually going to accept just the language of alternating zeros and ones. Of course, you might, sometimes English description could be a little bit ambiguous, I understand, but I'll try in the test to be as precise as possible. Okay. Right, the only thing I want to highlight, several things. Number one, when you actually need to draw the DFA, I will have similar requirements. Number one, for each state, you have to give some description about what the state really means. For example, this state here means we have read only the empty string. And this state here, that means we have read so far more zeros than ones, and etc. You got to give some description over there just to justify that your DFA is actually reasonable. And then the final state could be more than one. And also, remember we kind of asked you the question before, like what's really the difference between DFA and NFA? You can see something here. For the DFA, for every state, outgoing edges must cover the entire alphabet set, zeros and ones. You cannot miss anything. But when we get to NFA, you can miss. In some ways, it's flexible. Okay. Okay, and this one here. Okay, give a try. Okay. I think all of them are actually not difficult. Right. All right. Guys, we got about 6 minutes. You guys have a choice. Either we can do one of them together, or you guys are dismissed. Do you guys have preference? What should I take silence as? Do you want exercise together quickly? Thank you. You guys are amazing. Now, which one? Oh, yeah, that's good, good, good. Which one do you guys want to do? Yeah, third one is actually pretty straightforward, right? The first one is really insulting you, right? How about second one? How about second one? Okay. Oh, by the way, second one is interesting. Second one is incredibly easy if you can use NFA. But using DFA is slightly complicated, slightly. Okay. I'm going to copy the question description there, and then you guys try for 1 or 2 minutes, and then we can take a look. How about that? Oh, by the way, if you really find difficult to do number one, don't feel shy. You got to try, right? Number one is easy, but I'm not too sure, right? Yeah, one thing I also want to emphasize, so let's say you are given some DFA question in the test. At this stage, you're not required to really give the minimum number of states in the DFA. So if you really give more states than necessary, that's completely okay. Later on, we're going to cover how you can optimize it. Then we'll worry, okay? We can wait for 1 more minute, and as usual, I can find one volunteer to come over, draw your DFA. Everybody will criticize on that, or praise on that, either way, whichever way you want to look at that. Okay, I'm just going to switch to here. Yeah, this one's not hard, right? Definitely not. Yeah, when I give you any DFA in the test, I wouldn't give you a very difficult one. Yeah, that's not really the point for this course. I just want to remind you about the notation. Really? You want to try? Sure. Okay, please come over, be my guest. Use my pencil, write it. You can even use different colors if you want to. I got highlighter, I got different color. so you can use them if you want to. But anyway, okay, go ahead.
This is lots of sit
Yeah,
here
yeah,
and learn.
yeah. No, go ahead, go ahead. Yeah. Okay. So really, so rather than asking you to document every state, I can see your initial state already, which is good. Can you just briefly talk about? Yeah. Can I? Oh, you want
There we
to?
go.
Okay.
A little more documentation.
Very good. Okay, very good. Thank you. Thanks so much. You want to explain a little bit just before we
Sure.
start criticizing?
So basically, once you get in, if it starts with a 0, great. Maybe the next thing will be a 1, and then we're done. Or if you start with a 1, wait till you get a 0. Then if you're lucky, the next thing will be a 1, and you're done. If you're kind of looking at zeros, you can just keep waiting around for zeros until the next thing's a 1. Actually, I think if you're like have ones, you stay here with ones until you get the 0, which might get you to 0, 1. And once you're here, you have the substring. So after that, you really know what's going on.
Awesome. Thank you so much. Thank you. Thank you. Yeah, to be honest with you, I think a given one DFA, it's really hard to formally prove it that you really satisfy the given language. The best way to do it, how I would do it, is to come up with any counterexample, right? Anybody with any counterexample here? Can you have a string that does not contain 0, 1 as a substring, but that one can be accepted by the DFA? Or if there's a string containing 0, 1, but that one somehow is rejected by the DFA, it can go either way, right? Let me see very quickly. 0, 1, then, yeah. Yeah, it's pretty good, right? Kind of corresponding to what you guys wrote. I can try to look at it, stare at that maybe a little bit longer, but I will put a check mark for now. Okay. If you guys happen to come up with any additional counterexample, let us know. But it looks very reasonable to me. All right, guys, thank you so much. I'll let you go now. Okay, take care. See you on Tuesday.